Hi guys, so this video we're going to talk about parametric differentiation. So parametric differentiation here has to deal with functions which have parameters in them. That means we're given the functions with parameters in them. And functions with parameters are sometimes given as such. Maybe you have x and y separate. That means we're going to have x to be equals to maybe 1 plus t squared, where t is the parameter there. It could still be lambda or anything, just that it's a parameter. So, and it could still be y equals to maybe t plus t squared. So this is how the functions here are going to look like. Here they're no more given as one whole function, but they're given as terms of x and y, each having parameters of t. So to differentiate this, what we are going to do here, observe keenly. So let's try develop the equation for this. That means the formula how to do this. So originally, since we're given x and y, we're supposed to come out with the derivative in the form dy on the x. But how is that going to be possible? Meaning we're going to differentiate x separately and y separately? Yes. How is it going to be done? We're going to do it as such. We're going to have the x on the t, and we're going to have the y on the t. That means differentiating x, we're going to have the x on the t, and differentiating y, we're going to have the y on the t. So now how are we going to come out with the y on the x? Because if we multiply these two, we see that it doesn't come out as such. We should look for a way that if we multiply these two, we're going to be left with dy by dx. And if you check well, yes, possible. If we take the inverse of this, if we invert this, that means we take it to be now dt on dx. It's going to be possible. That means if we multiply this, we see that the t's are going to go and we're going to be left with dy by dx, which is simply going to be dy on the t times the t on the x, which is going to be equals to be dy on the x. So that's the formula to have that. So we'll take that question as an example. So it was x equals to 1 plus t squared and y equals to t plus t squared. So now if you find the derivative of d of x, so we're going to have the x on the t. So finding the x on the t is simply going to be normal differentiation. That's polynomial differentiation, as I'm saying. Keep on watching these videos, because for you to get really take a mastery of this, you have to solve over and over and study the different techniques. So if I differentiate 1, which is a constant, what am I going to have? I'm going to have a 0. If I differentiate t squared, we bring the 2 down here, we're going to have plus 2t to the power 1, and which is going to give me 2t. So that's the derivative of x. So let's take y now. So we know y is equals to t plus t squared. So taking the y on the x, we're simply going to have, so if we differentiate this, which is t, we're going to have a 1, because we bring it 1, the power is 1 here, 1 minus 1, which is 0, and into the power 0 is 1, plus this, which is going to give me a 2t. So I have my dx, sorry, here is on the t, not dx on the t to be equals to 2t, and I have my dy on the t to be equals to 1 plus 2t. As the formula says, dy on the x is simply dy on the t times dt on the x. So to have dt on the x, we have to invert this, which is going to be equals to dt on the x, which is going to give me a 1 on 2t. Good. Now, which is going to be equals to dy on the t is 1 plus 2t times this function multiplying dt on the x, which is 1 on 2t, and this simply giving us 1 plus 2t on 2t. That is the derivative dy on dx of that parametric equation. So guys, you really see that these things are really simple. It's just to play around with the all what we've been learning from the onset. So make sure you really take time to study this and subscribe. Give your problems, we're going to help you with that. So thanks for watching and stay tuned for more interesting videos.